When rivers exit mountain ranges, they are often packed full of sediment generated by erosion of the upstream landscape, and it's washed into the channel by rainstorms like you can see on the screen now. Sediment deposition downstream of mountain ranges like the Himalaya can also cause the river channel to change course and increase flood risk. Our research tries to understand how and where these rivers deposit sediment as they leave the mountain range. We do this by taking physical measurements of the sediment and water in these channels during the high flow season, aka the monsoon. And to do this, we use a boat, designed and built by Ed Tipper at the University of Cambridge. Thanks, Ed! We start by identifying accessible locations where we can launch the boat, often providing entertainment to local villagers. We then use a piece of equipment called an acoustic Doppler current profiler mounted to a bodyboard to measure information on channel geometry, water discharge and velocity, and to select the point in the channel to collect sediment samples from later. To get to this point in the day can often take several hours. Once we've selected a point in the channel, we load the sample up onto the boat and try and return to that same point in the channel. We then lower the sampler to different depths in the water column and take a 5-litre sample. This allows us to measure the concentration and the grain sizes of sediment being carried in suspension and observe how this changes with depth and distance away from the mountains. We then borrow more of Ed's equipment to filter our water samples in the evening, so we can extract the sediment which we then take back to the lab. But sediment also rolls and shuffles along the riverbed. Mikhail designed some very high-tech equipment to try and sample this sediment too. Again, we mount the bed sampler onto the boat and lower it onto the bottom of the channel. When we feel it's hit the bottom, we leave it there for a while and then hoist it up. Sometimes it's good to see that science doesn't always work smoothly. But we had some minor successes, hoisting up 20 kilograms of sand on one day and a big bag of pebbles at another site. Part of being a scientist is experimenting with new ways of sampling the river. And sometimes it's about just appreciating where you are.
Describe your feelings!
It's the best elephant. The only wild elephant I've ever seen.
Trying to understand and observe large-scale processes in big rivers can be unpredictable, but sometimes it rewards you. None of this would be possible without the help from Ed and also other collaborations we've developed over the past couple of years with Practical Action and KFZ. Hopefully these kinds of networks will help advance our understanding of how these phenomenal landscapes evolve, but also how we can translate and use this knowledge in a more practical sense. Thanks as always to our brilliant team, our drivers Tenzing and Subhash, and our boating heroes Rajesh and Ganesh.